first exhibit shows the raw materials and labors for each type of the computers, right? And the second one is, right, as I just mentioned, there are three types of machines, right? Raw material inspecting, soldering, and assembling. And the total machine hours of each type is listed here, right? And also the overall overhead cost associated with these three type of machines. And also the raw material handling will, like, the total amount of raw material handling is 200 and total cost is this one. And the machine adjusting is like setups, right? And the total amount of machine adjusting is 2,000 and with an overall cost of this. And also for packing. So this table shows the amount of each activities and also the overhead cost. Right? We can see the sum of these 6 overhead costs will be our overall overhead cost, 196 million. Right? And for the third table, it shows how many resources or overhead cost each type of computer uses. Okay. So based on this three information, our key question is what are the price of the product under different costing? For example, under traditional costing and under ABC costing, and what are the overall cost under these two costing? Okay, so we can look at our slides. So here we have three cost items, right? The direct material, direct labor, and overhead cost. So the overhead cost is what we are going to assign. And there are two ways to allocate this overhead cost. So the first one is the traditional cost calculation, which focus on unified overhead rate basis. Right, only one cost driver, and the ABC methods have different cost drivers. Right, so first for the traditional costing, as we mentioned, the overall overhead is 186 million, and they basically currently they are assigning this overhead cost on the basis of machine hours, right? Although we have three types of machine hours, right? But they only assign them based on the machine hours regardless of their types. Okay? So the total production hour here, three types of machine hours. The sum of three types of machine hours is 500K, right? Inspecting plus soldering plus assembling. And overall overhead cost is 196 million. So just first calculate how many it cost per machine hour, right? How many overhead cost per machine hour. So we just use this overall overhead cost divided by the total machine hours. We have like each machine hour will relate or will lead to an overhead cost of 392. Okay, this is the overhead rate. So next one is we need to calculate each type of computer. The amount of this cost driver, right? The cost driver is machine hour. So we need to calculate the amount of the cost driver each type of computer use. So from the table, from the information in the material we see, right? These are the three machine hours. And for the first type, overall to use 5 hours, right? And for the second type, overall to use 4 hours. So we have the first type use 5 hours of a machine, and the second type use 4 hours of machine. And each machine hour corresponding to an overhead cost of 392. first is 1,960, and for second is 1,568. Okay, so these are the overhead cost under the traditional costing, and based on the pricing rule, right, we need to sum up the raw material for type 1, the direct labor for the first type, and then we have the total production cost for the first type, right? In the same way, we can derive the total production cost for the second type. And this company's pricing strategy is to make a markup of 50%. So just this one times 1.5, we have the selling price of these two products. Okay, so this is the selling price under the traditional costing, right? And next we are going to talk about the costing under the ABC calculation. So the essential difference between traditional costing and ABC calculation is ABC use several cost drivers, but the traditional only use one, the machine hour, right? So in ABC we identify 6 cost drivers, okay? So the raw material handling, machine adjusting, packing, and also 3 types of machine hours. Now they are regarded as different cost drivers, right? Inspecting, soldering, assembly. So this one, 90 million, is the overall cost for this cost driver, raw material handling. And how many handling we need, or how many handling we have. So this is the number of, or amount of handling we have. We have 200 of handling. So for each raw material handling, we incur an overhead cost of this one, right? 450K. Okay. Again, for each machine adjusting, we incur an overhead cost of 6,000. And for each packing, we incur an overhead cost of 120,000. And for each hour of raw material inspecting, we incur a cost of 50. For each hour of soldering, the cost is 60. For each hour of assembling, the cost is 120. Okay, so this is the cost rate. So in this line, this is the cost rate for each cost drivers. Okay. And next, in addition to the cost rate, we also need to know how many, right? How many cost drivers? For example, how many orders for the first type used, and how many benches the first type used. Okay, and from the information, we say, okay, here, this is the budgeted production, which means the number of computers we are going to produce for each type, right? For first type, we are going to produce 20,000, and for second type, we're only going to produce 5,000. And the second data is here, the received order size. So per each order, we need raw material handling, right? And order size is 1,000. So this means for this one, we need how many orders? Right, we have 20,000 and each order is 10,000. So the number of order is 2, right? The number of order the first type uses is 2. Okay, and for the second one, the bench size is 5,000. So each bench we need packing them, right? Here, right? Each bench we need packing them. So how many packing we need for each type? we have 4 packing, and the second one we have 50 packing, right? And then is the setup. So machine setups per bench. So each bench we need set up machine 5 times for the first time and 6 times for the second time. Right, so remember that we have calculated that. For the first time we have 4 benches, for the second we have 50 benches. And each bench the setup is 5. So for the first time, the total setup we need is 20. And for the second is 300. Okay, so these are the calculations of how many orders, how many benches, how many setup we use for these 2 type of products. And next is the machine hours. 3 types of machine hours they used. Okay, it's very simple. So the second step, of course, here we calculate the amount they use for 6 cost drivers. The next step is very easy, right? We just, calculate the product between the cost rate and the amount each type used. So we use this times this plus this times this plus this times this. Okay, like the population here. So, and then we derive the total overhead cost that cotton 1000 used is this one. Okay, this is the total overhead cost used. And also, in a similar way, we can calculate the total overhead cost of cotton 2000 used is this one. Okay, and use these 2 numbers divided by the total production cost. We have the cost, the overhead cost per unit of the product, right? So each unit of cotton 1000 will cost an overhead cost of 425, and cotton 2000 will cost an overhead cost of 2740. Okay, so this result is much different from the previous one, right? Because the overhead cost, they are quite close, right? Of these 2 types. But after we use ABC calculating, we find this only costs 400, but this costs nearly 3000, right? And also, if we plus the raw material and the direct labor, we will have the total production cost for each type of product. And based on this, we also use the markup policy, right, to set the price. We will find the first type, the price is only 2000, and for the second type, it's have a price of 8000. Okay, so from this example, we can conclude that different cost estimating methods will lead very different price, right? If they follow a simple pricing policy like use a markup of 50%. Okay, so it's very important to select an appropriate costing to allocate the overhead cost. Okay, this is for the second part, the ABC costing. And next we are going to go through the exam paper. One of the exam paper in the previous year. Okay, remember that you can also find more exam paper here. Okay, here we have like 4 years exam paper. Yes, and the answer for the calculation answer for these 4 papers for exams, I will upload them this tonight. Okay, and in class we go through one of them. Okay, so first, the first question here is Q4A. Okay, so Q4 here. as a project manager, you have gathered time information on each activity of the project, and the time information is shown in this table. Here we see it tells us the time estimates are 99 confidence, right? So we use the divisor of 6, right? The formulation here, we use the divisor of 6, right? 99% we use 6, okay? So the first question is, calculate activity durations, so round off to 1 decimal place, and the variance round up to 2 decimal place for the activities. It's quite easy, right? Just follow these two equations, and substitute. This is A, right? This is B, and this is M. And substitute these 3 numbers into the 2 equations, we will have the result like this. Okay, 1 decimal place, 2 decimal place. Okay, this is very easy, right? For the first question of the Q4. And the second question, okay, describe the process for determining the critical path of a project using the network approach. So here is a specification that your discussion should include forward path and backward path. Right, so it is what I just using, right? Use forward path to determine the early start, early finish, and use the backward path to determine the late finish, late start, and then calculate the flow of the slack. Then those activities with zero flow or zero slack will be on the critical path, and you can identify the critical path. Right? You can see the answer here. So if an activity has zero slack, then it is a critical path, a critical activity. And so the critical path of this question is, there are 2 critical paths, okay? And the diagram is like this. B, D, E, F, G, O, B, F, G. Both of them are critical paths. Okay. And for the third question, we follow the approach you described in the second part. Draw the network diagram for the project and find out the critical path of this project. Right, we have found out, right? Draw the diagram, and also here it requires you use this AON diagram. Okay. And you need to show information of early start, early finish, late start, late finish, right? Just I have shown you. So you need to early start, early finish, late start, late finish. And this is duration, this is distribution, and this is the slack. Okay. And here, please pay attention. Here also another question. Also identify other passes and their durations. So you need to answer this. So the critical path, of course, is these 2, and the duration of the critical path is 49 weeks, right? And there are still another 2 passes, non-critical passes, right? And their corresponding duration is 39.5 and 48.5. Okay. And the next question is, what is the probability of finishing the project in 45 weeks? Okay, so the expected one is 49 weeks, right? 49 weeks is the expected one. And now the target is 45. So the first step, of course, is to calculate the variance of the critical path, right? And then derive the standard deviation. And then calculate the z, right? It equal to minus 1.33. So here, this is our target, and this is the expected. And we derive z, and corresponding to the standard normal table, right? We can find out the probability of this one, this 5 says that company is considering two different projects and decide to perform a financial analysis to determine which is more financially preferred. And project A and B have the cash flow shown in this table. And also, please note that the investment of first project were paid at the beginning. Okay, so there are two projects, and their cash flows and investment are also listed. So the question here is given, so it gives you the discount rate of 80%, right? You need to calculate the NPV, the net present value, the internal rate of return, and the payback period. Okay, so we have a result like this, right? So because the investment was made at the beginning of the project, right? So we don't need to discount the investment, right? And this 0.85 equal to this one, right? 1 over 1 plus 80%, right? This one. And just make a product between the discount factor and the cash flow. We have the present value of this cash flow. And also this 0.72 equal to 1 over 1 plus 80% squared. Then we have present value of this. Okay. So in the same way we calculate all the present value and sum of them with the investment. We have the NPV of project A and also the NPV of project B. And also we need to calculate the IRR, right? So remember that we can only use methods of plotting to derive IRR. Okay. So here the formulation of IRR is like make the NPV of a project equal to 0, right? The IRR means the rate. The discount rate makes the NPV equal to 0, right? And the formulation is the investment plus the cash flow in first year. If we use R to represent the rate, right? And plus the second, right? And plus, so here we have 5 cash flow, right? So we substitute the investment, the cash flow, and we can calculate this based on different rate, right? So use plotting methods. We substitute, for example, we substitute R equal to, for example, 20%. We may have an NPV, so this one may equal to, for example, I just give an example, for example, equal to 10,000. And then we also, like if we make a substitute of 50%, then may becomes minus 20,000. Alright, so these two equations tells us the IRR must be between these two, right? So we can, for example, substitute 45, right? And we may derive another one. Then when these two are a little bit close, for example, between 35 and 45, we have one positive and one negative, right? Then we just draw a figure and to identify the IRR, right? So this is how to derive IRR. And the third question is to calculate the payback period, right? So it's quite easy. Okay, so first year we can have a cash, for the first project, for first year we can have a cash like 20K, and second year we have 50K. So after 2 years, we still need to earn more like 30K to cover the initial investment, right? And so how many years we need more? use this 30K divided by the cash flow after the 30 year. We say we need to only spend 0.6 year in the 30 year to make all the cash flow to cover the initial investment, right? So here the payback period is equal to 2 plus 30K over 50K equal to 2.6. And in a similar way, we can calculate the payback period of project B. Okay, this is calculation for these three index. Okay, next question. So a company is planning for a project which would require the service of a senior engineer, a junior engineer, and a technical. And the annual salary of these three type of staff is 120K, 75K, and 30K. And also, this project will require 25 hours of the senior engineer, 40 hours of the junior engineer, and 60 hours of the technical. Also, their working will lead or will cause some overhead cost. Okay, so the cost have a rate of 30% of the technical and have a rate of 50% of the engineer. And also, in 1 year, each person will work 2,080 hours. And also, when they are working, the effective working time will be discounted, right? So they need a 50% of personal time when they are working. Okay, so the question is, what is the total labor cost for a project? So this question is essentially an ABC costing question, right? So it's essentially an ABC costing question. The three types of personal staff, senior, junior, and technical, actually they are three cost drivers, right? Three cost drivers. And the project, right? The project needs 25 hours for first person, 40 for the second, 60 for the third. And we can see their working will lead to some overhead costs, right? So the technical will use 30% of. So for the third, it will lead to 30% of overhead cost, right? So we need to time 1.3. Or in other words, we need to use this way. Also, it needs, every person needs these 50% and these 50%, right? And every person, they need some personal time, right? So we also need to consider their personal time. Okay. 55%. Okay, this is personal time. So from this we can get the actual working time we require from these three type of person, right, for this project. Okay, so this is the actual time we required from these three type of person. And next, another thing we need to derive is the rate, right? This is the total amount we use of these three type of stuff. Next thing is the rate, right? So the annually salary we have, and also the yearly working hours we also have. So every hour, how many we have. So this is the rate of the senior one, right? And also the rate of the junior one. And also the rate of the technical. then we have the labor cost of each type. Just to sum them up, we have the labor cost for the whole project. Okay. So it's more like basically we are based on the idea of ABC costing to derive the answer. Okay. And you also require to discuss some difference between these two costing systems, the traditional and the ABC costing. Okay, next question is question 6. So as a project manager, you will have gathered the time information for each activity of a project shown in this table, table 6. Okay, this is the crash information. Okay. And remember that here is a note. Partial crashing is allowed for all activities. Okay. So the first is ask you to draw a project network, identify passes in the network and their durations. So this question requires you to list all the passes, right? All the passes that burst the non and critical pass. Okay, and calculate their durations. This is not difficult. So we can list 3 critical passes here. And the duration is 35, 42, and 32. So the second pass is the critical one, right? 42 weeks. And the total activity cost before crashing were equal to the sum of all activities. Okay. So this is for the first question. And second, what is the total project cost without any crashing? We have just calculated this. And thirdly, crash the project so that it can be completed in 33 weeks. And find out the minimum cost to achieve this. So we need to determine which activities to be crashed to achieve this target, right? 33 weeks at a minimum cost. Okay, here also another requirement is you need to identify the sequence of activity to be crashed. Okay, so we need to follow several principles. First is the critical path, and secondly is the cheapest one, right? And also the earliest and most common one among the same cheapest, right? These are some principles when we are crashing. Okay, so the result is here. So of course, first we need to calculate the slope, right, of all these 7 activities, and also select the critical activities among them. So the critical activities are A, B, D, F, G, right? So A, B, D, F, G. And the sequence of crashing is begin with the cheapest one. Okay, so we begin with F, right? Only cost 200. Okay, so the first activity to be crashed is F because it is on critical path, has the lowest cost. Okay, and we can reduce F by 2 weeks. So after we crashing some activities, we need to re-identify the critical path. Because sometimes this will change, right? There will be more critical passes. And in this case, after crashing F, we still have this critical path, right? And we just keep calculation in this way, and we will have the result like this. Okay, so first we crash F to reduce the time by 2 weeks, and the cost is 400, and then we crash G by 2 weeks, the cost will increase by 5, and B also increased it by 5, and then D increased by 800. So at end we have a total duration collected the data in this figure about project progress, and it is the undervalue, okay, the undervalue and planned value of this project. So the question is comment on the project performance from an undervalue analyzed perspective. And can you conclude the project is on the right track or not? If not, what additional information do you need? So it's kind of an open question for you to discuss, right? And here are some suggestions for you to discuss questions like this. So you can discuss from these kind of perspectives. Okay. Okay, these are all the content for today's seminar. And if you have any further questions, you can email me or you can add my WeChat in the group. Okay. And this slide will also be uploaded